This video is a data analytics tutorial using Pandas. If in the previous video we looked at basic functions of Pandas, how to work with files, how to create basic visuals, analyze stats, in this video we will look into more advanced functions, for example, %change, rolling window function, lambda functions, advanced filtering, and advanced pivot. If you're new to this channel, I'm Karina. I have transformed my career from finance to data. I've been in data analytics and data science for over 10 years. I found Dataset at kaggle.com, link in the description to this video, and the file is called Online Sales Dataset. First of all, we need to import required libraries, so we are importing our Pandas library as PD. Second step, we need to read our file. We say name of our data frame df equals pd.read_csv brackets, in the brackets pass to our file, to our online sales dataset, and we will print head of our file to see how the 5 top rows of our dataset looks like. Let's quickly check data types of our columns. To do that, we say name of our data frame df.dtypes, and let's run it, and it gives us a list of all the columns and the data types. So we can see we have this invoice date, and it is an object format. To perform basic calculations in work with our dates, we will convert it to datetime. That's why we say df square brackets name of the column we are selecting. In our case, it is invoice date equals pd.to_datetime brackets, and in the brackets you indicate the name of the column you are converting. In our case, it is invoice date. If we go back and rerun our dtypes, invoice date is now in a datetime format. Let's add 2 new columns. The first column will be total. If you look at our dataset, we have a quantity of items sold, the unit price, shipping cost, and we have a discount, but we don't have total sales. So let's add a new column called total, which will be quantity multiplied by unit price or total sales, and we will adjust this number by a discount amount. We say df square brackets total to create a new column equals df quantity, or our quantity column, multiplied by df square brackets unit price, or column unit price, multiplied by 1 minus df discount, so 1 minus the % of discount. You can see that our discount price is, for example, 0.47, 0.19, so it is 19%, 47%, etc. Let's add this total column. Now if we print our head, and we can see we have a new column called total. Let's also add a new column called date. If you look at our invoice date, it's, for example, 1st of January 2020, and it's midnight, and then 1st of January 1 a.m., and then 2 a.m., 3 a.m. So it looks like our invoice date is a date time. So it is a date and a time of the invoice. But we will be working with total sales per date later on. That's why we need to create a new column called date. To create a new column, we again say df square brackets name of the new column we are creating equals df square brackets invoice date, because this is the column we are using to create a new column, dot dt dot date. And again, if we rerun our df head, we can see a new column was created, which is just the date, invoice date, not invoice date time. We will also add a new column weekday, because we will be creating a pivot by days of the week. So the first step, I will create a list called weekday order to put all the days of the week in the correct order. Otherwise, when you create a pivot, your days might start from Wednesday or Thursday, something random, but I wanted to start from Monday. That's why very first step, I'm creating a new variable called weekday underscore order equals, and it is a list of all the days of the week from Monday to Sunday. And now we are adding a new column called weekday. We say df square brackets weekday, or name of the new column, equals pd dot categorical brackets, in the brackets we say df invoice date dot dt dot day underscore name empty brackets, comma, categories equals weekday order, or the variable we've just created, comma, ordered equals true. Why we use a categorical? Because it converts this column to a categorical type with an explicit order from Monday to Sunday. Without this sorting by day names or strings would use a default alphabetical order instead of the order we need. And again, if we print our head, we can see we have a new column called Weekday, and if you double check a calendar, 1st of January 2020 was indeed Wednesday. The next step, I want to add a column which is a rolling sum. If we look at our dataset, it's broken down by invoice number, and different invoices have different days, but we want to create a new column rolling sums. That's why the very first step will be to group our data by date. We'll create a new data frame called daily sales. We say daily underscore sales equals name of the original data frame, or df dot group by brackets. We are grouping our data by date, and then square brackets total dot sum empty brackets dot reset index empty brackets. We will group our data by date, and the values will be total, and we want to get a sum of all our total sales. And if we print our daily sales, you can see this dataset has only two columns, date and total sales. And now we will create a rolling 7-day average number. You can change average to sum if you want, or maximum, but we will work with rolling average. So we will create a new column called rolling 7-day average. So again, we say name of the data frame, in our case it is daily sales, square brackets, name of a new column you are creating, rolling 7-day average equals daily sales, square brackets total, so the column we are working with, dot rolling brackets, in the brackets we say window equals 7, comma, minimum periods equals 7, dot min empty brackets. Window equals 7 means that we look at a consecutive block of 7 days to perform calculation, and mean periods equals 7 specifies that the calculation should only be performed when the window has at least 7 data points, which means that for the very first 6 days of our data we will have no calculation, because we need to have at least 7 days to perform this calculation. And this prevents from misleading averages based on incomplete data. So once we have full 7 days, we will calculate our average, and if there was no full 7 days, we can't make this calculation. And by saying dot min brackets, we are saying that we are calculating the average. Let's run head 21 because I want to show you these rolling averages. As you can see, first 6 days have no calculation because we don't have a complete data. But our calculation starts here on day 7, and this number is the average number for all these total sales. The next value is the average for other 7 days, from 2nd of January up to 8th of January. And that's how this rolling window works. So we are calculating average for 7 days. Rolling averages are often used in gaming, in different online stores, e-commerce, marketing. For example, a person downloaded Sims and started playing on day 1, didn't purchase anything, but then start buying on day 2, day 3, 4. Since people join on different days, you create this rolling 7 days. And for example, you know that in the very first week, people usually spend this much. So you compare everyone by this metric. So no matter if you joined in January or July, people compare your first 7 days to someone else's 7 days. Similarly, in sales, you can look quarter over quarter, this rolling days, rolling months. So that's how you can calculate that. Now let's look at percent change. So the very first step, we actually need to convert our date column to datetime, similarly to what we've done to our invoice date, because we will be resampling our data by months, and to do that we need to make sure that the date column is already in a date format. So the very first step, we say df square brackets date equals pd dot to underscore datetime brackets df date. And now we will create a new data frame called monthly sales. So monthly underscore sales equal df dot set underscore index brackets date square brackets total dot resample me dot sum brackets. And let's run it and see how this data set looks like. So you can see we have two columns, which is date and total sales. Since we've done resample me means month's end, you can see that all the date shows us the last day of the month. For example, this is total sales made in January, but it is displayed as of 31st of January 2020 instead of being sales on the 1st of January like we've had before. And it is important when you work with financial data, you usually want to present your dates end of months. So let me explain this line of code. So when we set df.set_index, it sets the date column as the index of our data frame. This is required for resample method to work. And of course, square brackets total, we are selecting the total column, which contains the total sales for each entry. And then we say dot resample ME resamples the data to the end of each month. That's why ME, month's end, and groups all the sales data within each month and creates a single value representing the months. And of course, dot sum brackets sums the total sales for each month. Now we'll create a new variable monthly sales growth. So monthly underscore sales underscore growth equals monthly underscore sales or name of our data frame dot pct underscore change brackets multiplied by 100. And now if we print this, we can see month over month growth. You can see that sales in February are actually down by 3.5%. Then in March, sales are up by 6.5% compared to February. PCT change calculates the percentage change between consecutive rows. We can compare February to January, March to February, etc. And we use this multiply by 100 because we want to convert the decimal output of PCT change into a percentage. Now let's look at advanced aggregation and transformation. So we will create a custom function for our profit margins. In our dataset, we also have shipping cost, which impacts the profit margin, impacts how much we actually make from each of the sales. So let's calculate a profit margin column. And this time we will create a custom function. So in Python, to create a function, you always say def, or like defining the function, then the name of the function you come up with, and then colon. And always you need to return the value at the end of your functions. We say def calculate underscore profit underscore margin brackets row colon, and then our condition if pd.isNA brackets row square brackets total or row square brackets total equals 0 colon, then in that case we will return 0. Otherwise we need to return row square brackets total minus row shipping cost divided by row total multiplied by 100. So let me explain to you what is happening. This function calculates the profit margin for each row in the data frame. The results of this function will be applied to a new column which we will call profit margin. So we added this condition if a Pandas is NA row total or row total equals 0, then we return 0. So we are adding a condition to handle the cases where total is missing or equals 0. And in that case, we return a profit margin of 0 because we want to avoid errors when we divide in by 0. So if we have 0 somewhere, we can create an error. It will say that you can't divide by 0. But by adding this if statement, by adding this condition, we can avoid that. And what are we returning? We're returning a row total minus a row shipping cost divided by a row total multiplied by 100. So we're subtracting shipping cost from our total sales, and then we divide the profit by the total to calculate the profit margin as a percentage. And we need to add a new column called profit margin to our data frame. So we say df square brackets profit margin, or name of the new column, equals df dot apply brackets, and what we're applying, we are applying the function that we've just created, calculated profit margin, comma axis equals 1. df.apply applies the function we mentioned. We apply in our function row by row, and to indicate that we say axis equals 1. And if we again print head, let's have a look. You can see we have a new column called a profit margin, and for example here it is none because our total is actually minus, is below 0, and I think it is sales returns. That's why quantity is minus, unit price is minus. Interesting that return status is non-return, but everything has minuses, and of course our profit margin is minus in that case too. If it was a proper data analytics project, you need to investigate what is this minuses. If it is sales returns, they must impact the total sales, the total revenue, so you need to include them. But if it is some cashbacks or errors, then we need to exclude them and analyze them separately. So if you're excluding something, you always need to indicate, you need to add an asterisk and say all the negative sales were excluded and the reason being why you excluded. If you included them, then you also add asterisk and explain that the breakdown includes negative sales and explain why they included. In data analysis and finance, you can't just simply exclude numbers if you don't like them, if they don't look good on your chart. You need to always indicate why you're doing this and what it means. Now let's look at country level analysis. We will work with advanced aggregation for that. We need to create a new data frame called country_analysis equals name of our data frame df.groupby. We are grouping our data by country, so in the brackets we say country.agg brackets. In the brackets we use curly brackets because we are working with a dictionary, and dictionary in Python is a key value pair. So first part is a key, second part is value. So how we are aggregating our data. For our column total, we want to get sum or total of totals, we want to get average, and we want to get count. You've seen before when we were doing aggregation, we would say total, I want sum, and for discount, I want average. But this time for one column, we want to get several aggregations. We say total colon square brackets because we are creating a list of our aggregations, and we say sum, comma, mean, comma, count, comma, then the next key value pair. For column discount, we want to get average or mean, comma, we want to get this lambda x, where x over 0.3 point sum. This way we are creating a custom function to count how many transactions in the country have a discount greater than 30%. And of course you can adjust the number if you want. This way I want to show you how you can add this custom function. Then for our profit margin, we want to get average and median, and then for custom ID we say pd.series.n unique, or we want to count the number of unique customers in each country. And then we close our curly brackets to close our dictionaries, and we close our brackets, and we say dot round to, because we want to round all aggregated results to 2 decimal places for better readability. Let's run this one. Let's run country analysis and look at our data set. As you can see, we grouped our data, which looks like a little pivot where each row is a country, and then we have these values. So for our total sales, we have the number of all the sales, or sum of all the sales for each country, average sales for each country, and the count of sales. And we count how many transactions in the country have a discount over 30%. Then for our profit margin, we get a median profit margin and average profit margin, and we count how many unique customer IDs we have for each country. So with this group by and aggregate a function, I showed to you how you can use one column and get different metrics for it. So for the same total, you can get average, count, sum, max, mean, whatever you need. You can also create your custom function with lambda, and of course you can use .n unique when you want to count number of unique customers, number of unique transactions, sales, etc. Now let's have a look at advanced pivot tables. So first pivot table we will create called a sales pivot. That's why we say sales underscore pivot equals pd.pivot underscore table bracket. In the bracket at first you need to indicate your original data frame, in our case it is df, comma, our values will be total and quantity, and because we use more than one value, we use square brackets to indicate the list of our values, so total and quantity. For our indexes, we use also a list, which will be country and category. Our columns will be weekday, and we want to create also aggregation. So you can see we set aggregate function, curly brackets, again, key value pair, our key will be total, and we want sum of total, and for quantity, we want average. Fill underscore value equals 0, and once we close our brackets, we say sort underscore index level equals 0,1. So when we say values, we specify the metrics to aggregate. For index, we selected country and category, meaning that rows are grouped by combination of country and category. For columns, we selected weekday, so columns represent the day of the week from Monday to Sunday. Fill underscore value equals 0 fills any missing value values in the pivot table with 0, and sort underscore index ensures that the pivot table is sorted by the hierarchical levels, country and category. Now once we run it, you'll see what I mean. So you can see that our rows are countries and then categories. So for each country we have a category. You can see that for quantity we have data from Monday to Sunday, for our total also from Monday to Sunday. That's why we at the beginning we had to create that weekday list where we specify the order of days, because if you haven't done that at this stage of pivot table, all the columns will be in a random order, but we wanted to make sure it's from Monday to Sunday. And you can see now we have this more sophisticated pivot which you can create in Excel, where you have different levels, where it is country level, category level, and then different types of columns, and of course aggregation of these columns. So for example, for quantity we have average, and for total we have sum. The next thing we will look at called cross-tabulations. The code we will use creates a cross-tabulation, which is a pivot-like table that shows a percentage contribution of each product category to the total sales within each sales channel. To do that, we'll create a new data frame called channel category. So we say channel underscore category equals pd.cross-tab brackets. In the brackets we say df sales channel, df category. Our values will be df total, aggregate function will be sum, normalize equals index, and once we close our brackets we say multiply by 100. df sales channel specifies the rows of our table where each row corresponds to unique sales channel. df category specifies the columns of our table where each column corresponds to a unique product category. Values equals df total indicate that the total column representing our sales is the value to aggregate. Aggregate function equals sum indicate that we want to get total sales of our total column, and normalize index normalizes the result row wise, so each row represents the percentage distribution of sales across categories for that sales channel, and each row will sum to 1 or 100% after scaling. And then we multiply everything by 100 because we want to convert the normalized values from proportions into our percentages. And let's run channel categories. You can see it looks like a little pivot table, but actually it is a cross tabulation or cross tab. Our columns is categories, our rows are sales channel, and it is a percentage, so you can add them all up and you can see that they will add up to 100. Let's do product analysis. We again will use our lambda function. We say product underscore matrix equals df.group by brackets in the brackets description, then .agg for aggregation, brackets again curly brackets, and then we indicate how we aggregate our data. So quantity will be sum, total will be sum, invoice number count, and then we close our curly brackets, we close our ordinary brackets, then we say dot assign brackets, and we say average order value equals lambda x colon x total divided by x invoice number, and then we will also have a units per order, and then again we say equals lambda x x quantity divided by x invoice number, then we close in these brackets, and then we round in our data to 2 decimal points. That's why we say round brackets 2. So you already know what aggregate function is, that we aggregate in quantity by sum, total by sum, invoice number count. I don't need to explain that, but let's talk about dot assign. So dot assign adds new columns to the group data frame using calculated values. So we are creating this average revenue per order for each product, and then we are also creating this units per order, the average number of units sold per order for each product. And let's print this. And you can see that we aggregated a quantity by sum, total by sum, invoice number, count, and then we have this average order value and units per order, which were calculated row by row. So it was total divided by invoice number or quantity divided by invoice number. Let's look at advanced filtering using .query. I like this method a lot because it is easier to read, it's easier to understand what you are filtering, but at the same time you have to type more. We say hi underscore value underscore transactions equals df or name of our original data frame .query, and then brackets. In the brackets we say where total is greater than total.mean brackets and discount is less than 0.02 and return status is not returned. That's why we say and return status equals not returned, and not returned need to be in double quotes because it is a string and the whole statement is taken in a single quotes. Let's run it. And now if we run these high value transactions, so our return status is not returned, our discount is less than 0.2, and the last thing we will look at is category performance. We say category underscore performance equals df.group by, we are grouping by category, .agg brackets, then again a dictionary total, we are aggregating sum as average and as count. Discount will be average, and for return status we say lambda x, where x equals return dot mean or average multiplied by 100, and we round all this data to get only 2 decimal places. Then we say category underscore performance dot columns, and we rename all our columns. So our columns will be total sales, average sale, number of orders, average discount, and return rate, and let's print it. That's the result. This group by, we are grouping the data by the category column, where each unique category represents a group. So again, total, we aggregated, we got total sales, average sales, and number of transactions. That's why we said count. For discount, we wanted to get average discount applied across all transactions in each category. And let's look at our return status. We created a custom lambda function that calculates the percentage of transactions returned. So x equals returned creates a Boolean series, and Boolean in programming is true or false, 1 or 0. So this x equals return creates a Boolean series, true for returned transactions and false for otherwise, so non-returned. Dot mean calculates the mean of the Boolean series, effectively given the proportion of returned transactions, and 100 converts the proportion into a percentage. And of course, round 2, we round all aggregate results to 2 decimal places for better readability. And then we are renaming all our columns for clarity, and that's why we created this category performance.columns, and we created a list. And now we can look at the details. In this video, we created a data analysis, and we'll look at more advanced Pandas functions that you can use in your daily work life, and you can also use when you work on your portfolio projects.